Good evening to all of you. I welcome the audience to this discussion on rotation molding and blow molding. As some of you are well aware that we have been discussing the processing techniques for plastics in our last few lectures. Just to revise what we have covered till now, we started our discussion with the differentiation between the thermosets and thermoplastic in lecture number 1. And then we have discussed one of the important techniques of processing of plastics, that is casting. In subsequent discussions, we have discussed the basic principles of some of the processes such as transfer molding, compression molding, injection molding, extrusion, and today we are going to discuss two important processes, that are rotational molding and blow molding. Now, the importance of these two processes lies in the fact that these two processes are used for making hollow plastic parts. In our last lecture, we have discussed the important process of thermoforming, in which we have seen that the raw material is in the form of a sheet, and this sheet is heated, and under heated condition it gets softened, and this softened sheet is then deformed according to the shape of the mold by the application of pressure, and this pressure can be applied either with vacuum, or it can be applied with the help of air pressure, or it can be applied with the die and punch type of mechanical arrangement. So, different types of raw material, that is plastic in this particular case. In module number 4, as you know, we are discussing processing techniques for plastic. So, the raw material in all the cases would be a plastic material. It may vary, it may be in the form of powders or pellets, as we have seen in the case of injection molding, or it can be in the form of a sheet, as in the case of thermoforming. So, the type of the raw material may vary, but basically it would be a plastic material only, and we have to convert this plastic material into the final product. The products may also vary. We have seen for each process what are the advantages, disadvantages, and what are the application areas of that particular process. So, if you remember, the total conversion stage from the raw plastic into the final product can broadly be categorized into three important stages. This particular point I have emphasized in all the lectures on processing of plastics, that three important stages are: stage number 1 is the heating stage, in which the raw plastic is heated and in many cases it is melted. The second stage is the forming stage, in which the molten plastic, or we can say heated plastic, as in case of thermoplastic, the sheet is heated but it is not melted, it gets softened on heating. So, the stages may vary, that up to what temperature we are heating and what is the effect of that heat on the properties of the raw material. Sometimes it may get melted also, and this molten plastic will then be deformed. So, the stage number 1 is the application of heat, or in single word we can say heating. Stage number 2, or the second step, is the forming. In forming, we are changing the shape, we are giving the final shape to the product or to the plastic, which we want to convert into the final product. And the final stage is the cooling stage, in which we allow the final product which has been formed by the first two stages into a, we can say it is now into a usable form when it cools down. So, the three stages primarily are heating the raw plastic, forming the raw plastic into the desired shape, and then allowing the final shape to cool down inside the mold cavity. And the last stage is the ejection, in which the final product which has cooled down is taken out from the mold. So, basically in all the processes our focus primarily has been on heating the raw material, forming the raw material according to the desired shape by the application of pressure or by some other means, and finally allowing it to cool to take the desired shape. And the last part is the ejection of the final formed product out of the equipment. So, in rotational molding and blow molding also, our basic steps or basic mechanism would be same, in which we will have a raw material. This raw material would be heated and then it would be deformed, but the deformation may be different. In this particular case, the application of pressure may be different or the mechanism of forming may be different, and finally it would be allowed to cool, and the final product after cooling would be taken out from the mold. So basically, important difference between rotational and blow molding with the other processes is that these two processes are used to process hollow plastic parts. So that's why these two processes have been clubbed together and are a part of today's discussion. So we will try to understand the basic principle or the basic working of the rotational molding and the blow molding process, and we will see diagrammatically that how the process is actually accomplished. Now, rotational molding process. On your screen you can see the rotational molding is a high temperature and low pressure plastic forming process, which means that we will heat the raw material to a desired temperature, but the application of pressure is not that high. If you remember, in our previous discussion we have discussed the thermoforming process, in which the plastic sheet was heated to a particular temperature and then a pressure was applied to deform the sheet so that it conforms to the shape of the mold. So the pressure was also substantial. Here lot of pressure will not be applied, only the raw material would be heated to a particular temperature and then under the application of certain type of forces it would be deformed into the desired shape. So the powder is inserted into the closed split mold. Now there are 2 or 3 important words here: closed, split and mold. Mold word we have been using number of time, but closed split means that the mold here is made in 2 parts, or it can be split open into 2 parts, and when these 2 parts would close together they will form a closed split mold, and the mold is rotated about 2 axes to produce a hollow part. I have already emphasized that rotational molding and blow molding are the 2 processes which are used for forming of or processing of hollow plastic parts. So here this particular mold would be rotated about 2 axes, and the 2 axes we can call as the primary and the secondary axis. So let us try to understand the rotational molding process with the help of a diagram. So on your screen I am going to draw a very simple diagram which represents the rotational molding process. Now this is the platform which is supported by the frames. Now this is, we can see a platform on which the mold is mounted. As we have seen, we use a closed split mold. Now this is a mold. So we have a mold, and then we have 2 axes. These are the axes that I am drawing on your screen. One is a horizontal axis, another one that I am drawing on the screen now is the vertical axis, and this is our mold. As it has already been mentioned, it is a closed split mold that it can be opened into 2 parts to take out the final product, and we have the 2 axes, the vertical and the horizontal. This is the horizontal axis. So, we have a vertical axis and a horizontal axis, and the mold is rotated about these two axes. Now, this is the rotation about the primary axis. This we can call as the primary axis, and we can have a rotation about the secondary axis. So, this is the secondary axis. So, we have primary axis and the secondary axis, and the mold would be rotating about the primary axis for a given number of rotations and the secondary axis for a definite number of rotations, and the raw material is inserted inside the mold. So, we may have an opening at the top for inserting the raw material. So, the raw material would be, in this case, can be a plastic powder or plastic pellets. So, this mold is also heated. So, we may be using a heated mold. So, the mold is heated, and when the raw material is put inside the heated mold, it fuses together with the adjacent pellets, and finally under the rotation this particular material which is present inside the closed split mold is thrown out towards the walls of the mold, and it sticks to the walls of the mold, although we have a non-stick type of coating, so that the final product that we form do not stick to the walls of the mold. But certainly under the influence of the forces that are generated because of the rotation about the primary and the secondary axis, the material would be thrown out towards the walls of the mold, and it will take the shape of the walls of the mold, and finally after opening the mold the product would be taken out. So, this is a simple representation of the rotational molding process. Once again we can see how the process actually takes place. The raw material is inserted in the form of pellets or powder inside the closed split type of mold. The mold is rotated about the primary and the secondary axis. The mold in this case is a heated mold, and because of the heat the raw material fuses together with the other we can say pellets or the other powdered form raw material, and because of the force generated because of the rotation of the mold, the raw material is thrown out towards the wall of the mold, and because of the rotation about the two axes the material goes and settles down or conforms to the shape of the mold, and finally after the material has cooled down the closed split mold is opened and the final product is taken out from the mold. So, we can make axisymmetric type of components using the rotational molding, and as has already been highlighted that this particular process of rotational molding of plastics is used for making large hollow axisymmetric parts. Now, let us come back to our discussion. Rotational molding, as is clear on the screen, is a high temperature low pressure plastic forming process. We have tried to understand this process with the help of a diagram. Powder is inserted into the closed split mold. As I have already told, the raw material is in the form of a powder, and the mold is rotated about the two axes to produce a hollow part, which has already been explained. Now again let us revise this with the help of a complete diagram. The diagram was earlier drawn. This is the heated mold. It can rotate about the secondary axis, it can rotate about the primary axis, and this is the inlet for the raw material, and on this rotation the raw material would be thrown out towards the walls of the mold, and it will conform to the shape of the walls of the mold. After the cooling has taken place, the split mold can be opened and the final hollow part can be removed from the mold, and now the process can be repeated number of times to make similar type of identical products. Now, what are the important process parameters? As the process does not seems to be very difficult, but there are few important process parameters which have to be controlled so that we are able to get a good quality hollow plastic part or a hollow plastic product. So, what are the important process parameter? Number one is the amount of the powder, because a metered amount, a measured amount of powder has to be put inside the mold. So, that is one important parameter. Heating temperature and time is also very important. We cannot heat too much, and if we are not able to provide the optimal heat to the raw material, then the fusion between the powder may not take place and we may not get a continuous product. So, an optimal amount of heat has to be provided for the metal or the sorry not the metal but the plastic powder to form a complete product. So, we have to provide a specific temperature, or we can say a specific amount of heat has to be generated so that the raw material is converted into the final product. And we have also to decide that for how much time this particular heat has to be provided, along with the rotation of the mold about the primary and the secondary axis. So, we have to decide on the rotational speeds of the mold also. And finally, last but not the least, we have to see that for how long the mold would be kept closed after the product has been formed inside the mold. So, these are the four important points that have to be taken into account if we want to make a good quality hollow plastic part using the rotational molding process. Once again, let us revise that what are the important key points that we have to keep in mind when we are going or planning to make a product by the rotational molding process. First and foremost, we have to decide the amount of plastic powder which is going as a input into the rotational mold. Second point is the temperature, for how long we have to maintain that temperature or how much heat we have to supply. That is another important point which has to be taken into account, and the temperature that we are maintaining or the heat that we are inputting will certainly depend upon the type of the plastic material that we are planning to form using the rotational molding process. So, it will depend upon the type of the plastic and the type of the powder that we are using. So, the maintenance of the temperature is equally important, the time duration for which we are going to maintain that temperature is equally important, and finally at what speed we should rotate the mold about the primary axis as well as about the secondary axis. That is also very important. And finally, we should control the time for which the part would be present inside the mold after the forming of the part has taken place. So, cooling rate is also very important. Important point is that how much thickness we want. Now, depending upon the thickness required, we have to decide on all these parameters, because if we want a thicker wall thickness, we may have to manipulate the parameters accordingly, and if we want a thin walled section of the rotational molded product, we have to then manipulate these things accordingly. So, these are the four important process parameters. There can be many other process parameters depending upon the shape, the type of the final product that we want to produce, but certainly these four would be common in most of the cases, that how we should control these parameters so that we are able to get the product as designed or as desired for a specific application. So, these are the important points to be taken into account. Now, what are the materials that can be used as the raw material in case of rotational molding? Thermosets and thermoplastic materials can be used. For example, low density polyethylene LDPE, high density polyethylene HDPE, polypropylene, polyvinyl chloride. So, these are some of the examples of the materials which can be used as the raw material in case of rotational molding process. What are the advantages of this process? Allows molded threads and mold in inserts. This is one important application of, or we can say advantage of rotational molding, that if we want to have threaded sections in the final product, yes, we can do it using the rotational molding. So we can because this process allows molded threads and mold-in inserts. Second important advantage is a wide range of surface finishes can be got. Yes, because the outer periphery of the product would be in contact with the mold. So the inner finish of the mold would be duplicated on the outer surface of the final product that we are getting. So if we have an excellent finish on the inner side of the mold, that finish would be duplicated on the outside of the final product. So rotational molding process allows a wide range of surface finishes, and we can control the surface finish of the final product which has been made by rotational molding process. And also in many of the cases, no finishing or no coating of the product would be required, because the integral surface finish that we get out of the process is sufficient enough for many applications. So the waste in this particular case is also minimized. Why? Because we are inputting the metered amount of raw material only, so there are chances of less wastage. So as it has been discussed that the metered amount of the raw material is put as a input into the rotational mold, so the wastage is minimum. Also you can see on your screen that the residual stresses that are developed are minimum in case of rotational molding. Also, once a mold has been made, it can be used for making a large number of parts. So the tooling requirements are not that expensive in case of rotational molding. Another advantage of the process is that additives for weather resistant flame retardation can be incorporated. As we are giving the input, the metered amount of the plastic powder as a input, if we want to make a part which has to have certain specific requirements, like it has to be used for a overhead water tank. A overhead water tank we want to produce by a rotational molding process, we feel that it should have weather resistance, it should have flame retardation. So in the input stage only, when we are inputting the plastic powder, we can put the flame retardation pigments or the weather resistant pigments into the raw material only, so that the final product that we get is having these type of characteristics. So it is resistant to weather, as well as it does not catch fire easily. So there can be a number of advantages that we can derive out of the rotational molding process. So we can see once again, let us revise. Molded threads and mold-in inserts can be easily incorporated in rotational molded products. Wide range of surface finish can be achieved because it depends upon the finish of the mold surface. Wastage is minimum. Residual stresses are also less in the rotational molded parts. Tooling is not very expensive. Also we can incorporate flame retardancy and weather resistant additives in the raw material, so that the product that we get can be used for these specific requirements. But apart from having all these advantages, there are certain limitations also. So let us see what are the limitations. So limitations are the slow production speed, because we have to rotate the mold about the vertical and the horizontal, or we can say the primary and the secondary axis. So the spread of the raw material to the walls of the mold may take some time. So the process is not very fast as compared to some of the processes we have seen earlier which are used for processing of plastics. So one of the limitation is that it is a time taking process. It usually takes about 1 hour to complete the process. This is in one specific case. We cannot generalize that it would take 1 hour only, depending upon the size, depending upon the type of plastic we are processing. This particular time may be less also, and depending upon the shape complexity, we may require sometimes additional time, so that the powder or the plastic is able to fill each and every corner of the mold cavity. So this is just a representative time. It may vary from lesser amount to a higher amount, and moreover the precision that we get is not very high. So another important point that we can note in case of rotational molding is that the outer surface finish can be easily controlled by the finish of the mold, but the inner finish of the final product sometimes have to be taken into account. So that sometimes may require certain additional finishing operations at a later stage. Why? Because we are inputting the raw material from top and at the heated mold is being used. Now because of the rotation, the raw material would be spreading or would be forced out to the walls of the mold. So the outside surface finish can be good, but the inside finish of the final hollow product sometimes may be an issue. So that is also can be one of the limitations of the rotational molding process. Now what are the applications of rotational molding? So the products that can be manufactured using rotational molding include storage tanks, as I have taken an example of a over we can say over a building when we use a water storage tank that can be made by the rotational molding process. We can use bins and refuse containers which can be made by rotational molding. Airplane parts can be made, road cones sometimes we see along the road, those can be made by rotational molding. Footballs, helmets, rowing boats, there can be, the applications are huge which can be made by the rotational molding process. Now coming to our second process that we want to cover today, that is blow molding. So one of the common feature between rotational molding and blow molding is that both these processes are used for processing of plastic parts which are hollow in structure or hollow in nature. So blow molding is a plastic processing technique which is used to produce hollow plastic parts by inflating a heated plastic until it fills the mold and forms the desired shape. So the raw material in this case is sometimes called a parison, and this parison can be made by injection molding process. So the raw material or the raw plastic part which is used as a input in the blow molding can be made by injection molding, which is another process for making plastic parts, or the raw material for blow molding can also be processed by extrusion sometimes. So blow molding is a process in which we will be making hollow plastic parts, and the raw material in this case would be a parison which would be used as the raw material, and in this particular parison we would be injecting or we would be inflating this raw material so that it takes the shape of the mold cavity. So we will try to understand this process with the help of a simple diagram. So let us see the diagram. On your screen you can see this is, we can say, a inlet from where the air would be blown. Then we have to have a mold cavity. Now this is the raw material. So let me, this is our raw material that we want to form, and this is our final shape. This is the final shape that we want to generate. So when the air would be blown inside this raw material, the raw material is often called a parison. So we have a raw material and a hot air is blown inside this parison. This is our parison, the point, the area that I am highlighting. This is our raw material. The hot air would be blown inside this and this would inflate to take this shape. It would inflate under the influence of the hot air which is blown inside and it would take this particular shape. So this is the raw material and the name suggests blow molding. So blow means we are blowing air and molding means that the raw material is taking the shape of the mold. So the mold is also clearly shown. It is a two-piece mold. We can say it can be divided into these two along this line. So it is a two-piece mold. When it closes down, the raw material comes inside, hot air is blown inside the raw material. Raw material is called a parison. It is a plastic part and under the influence of the hot air, this plastic parts inflates and takes the shape of the mold. Most of the plastic bottles are made by the blow molding process. So let us now try to see the theory behind the blow molding process. On your screen you can see that blow molding is a plastic processing technique which is used to produce hollow plastic parts by inflating a heated plastic until it fills the mold and forms the desired shape. So in the diagram we have seen that there are 2 or 3 important points. First important point is the raw material. So the raw material is a heated plastic which is also called a parison. Second important point is how it will get inflated. It will get inflated under the jet of air which is input or which is, we can say, coming from the top. So we have a air jet, we have a heated plastic and we have a mold. So the mold would conform to the final shape of the product that we want to produce. So inside we have the air jet would inflate the heated plastic and the heated plastic would inflate and finally it would touch the boundary of the mold, the inner boundary of the mold as we have seen in the diagram, and once it touches the inner walls of the mold, it would take the shape of the details that are present on the inner walls of the mold. It would be allowed to cool and after the cooling has taken place, the mold would open and the final product would be taken out. So different types of products can be made by the blow molding process. So let us now see and try to understand the 4 steps involved in the blow molding. As I have already drawn one diagram to explain the basics of blow molding, let us again see. This is the parison or the heated plastic raw material. You can see the arrow is indicating the raw material. It would be available in this particular form. It can be made by injection molding process which we have already covered. Then this is the 2 parts of the mold, part number 1 and this is the second half of the mold, and this is the inlet for the air from where the air would be coming in and filling this particular molten, not molten but this particular raw material or heated plastic material. So mold is there, heated plastic raw material is there and an inlet for air is there. Now in point number 2 or stage number 2, you can see the 2 halves of the mold have closed down and they have formed a cavity like this. This is the final shape that we want to produce. The 2 halves of the mold have now clamped together or joined together, holding the raw material inside. Air would be injected from here and it would inflate this raw material and it would take the shape of the mold cavity. It would take the shape of the mold cavity. This is the shape of the mold cavity. And once it has cooled, the 2 halves of the mold would open and we will get this final product. So in stage number 4, the 2 halves of the mold have opened up and it has taken final product has been formed, and the air supply is there in stage number 2 and to some extent in stage number 3, and in 3 to 4 the cooling is taking place, and in stage number 4 there is no supply of air, only the mold halves open and the final product is taken out. So it is a 4-stage process, stage 1, 2, 3 and 4. Stage 1, raw material is fixed, 2 halves are open, 2 halves of the mold closed down, air is injected, raw material inflates, adheres to the wall of the molds, the mold open and the final product is taken out. Now what are the important process parameters in blow molding process? As you can see, melting temperature of the plastic material, because although it is not melting, we should not write melting, but the temperature at which it can be deformed. So the temperature at which the plastic can deform and it can inflate and adhere to the walls of the mold, that is the temperature which is very important. So that has to be taken into account. Then second is the air pressure required, that how much air pressure is required so that we can inflate this parison to touch the mold walls. And finally the cooling time, the amount of time for which the two mold halves would remain closed for the final product to form, and when the two mold halves would open and the final product would be taken out. So this particular time is important. So if it is a fully automatic process, and if all these 3 parameters are known, the temperature at which the plastic has to be used, the pressure at which we have to inflate the raw plastic, and finally the amount of time for which the mold halves would remain closed, then the process can be automated and number of products can be made in a minute. Sometimes in an hour hundreds of products can also be made. So this is a fully automatic process which is blow molding, and it is used for making hollow plastic parts. Now what are the materials that can be used for blow molding process? Different types of thermoplastic materials can be used. For example, high density polyethylene, HDPE, LDPE, polypropylene, polyvinyl chloride, polyethylene tetrafilate, as we sometimes use this word quite often, PET bottles. So these PET bottles are made by the blow molding process, and sometimes polycarbonate can also be used. Now what are the advantages of the blow molding process? We can see low tooling cost and fast production rates, as I have already emphasized when we were discussing the basic working of the blow molding process, that it is a very fast process, the production rates are extremely high and the tooling cost is also not that much. So this particular process can be used for mass production as the production rate is very high. Ability to mold complex parts. If you see many PET bottles or these soft drink bottles sometime, or mineral water bottles, when we see, there are fine intricate details on these bottles. So these particular details can be easily incorporated using blow molding process. Little scrap generated. Scrap generated is minimum in case of blow molding, because the parison that we are using is blown out and it takes the shape of the final product. So there is no wastage literally. Large hollow shapes can also be produced. Produced parts can be recycled. Even there is a lot of work going on in the recycling of plastics. So the parts that we are making out of the blow molding process can also be recycled. But there are a few limitations also. And what are the limitations? The limitations are that the process is only limited to the hollow parts. Why? Because we have a hollow plastic raw material which we are inflating by the air pressure. So this particular process is suitable for hollow parts only and cannot be used for solid parts. Thick parts cannot be manufactured. So the wall thickness in case of, we can say, blow molding is limited, so we cannot make very thick part products using the blow molding process. Now let us see what are the application areas of blow molding. Some of the applications of blow molding are: different types of plastic products can be manufactured by process, such as bottles in different shapes and sizes. Different types of bottles can be made, plastic bottles. Jars and containers can be made. Ducting can be made by the blow molding process. Fluid oil tanks, mugs and toys can be made by the blow molding process. So the blow molding process has got lot of applications and it is being used widely for the processing of hollow plastic parts. So with this we come to the end of our discussion on the processing of plastics. But one important point that is left, which I have already emphasized in the end of lecture number 6, is the secondary processing of plastics. Although it is not a well developed, we can say, science and technology, but in many cases the machining of plastics is also done in order to facilitate the assembly of various plastic products to the other plastic products or to other wooden or metallic products. So secondary processing is equally important, although most of the plastic parts are made to the near net shape. So many processes can be used for processing of plastics. Out of that, some of the processes we have already covered. To revise what we have covered in processing of plastics, we have seen the casting process, we have seen transfer molding, we have seen compression molding, we have seen extrusion of plastics, we have seen injection molding of plastics, thermoforming of plastics. Within thermoforming, we have seen different process variants of thermoforming, and today we have seen blow molding, rotational molding. So all these processes can be used for processing of plastic parts, but most of the parts that would be produced by these processes would be used readily, or the parts that we get are near net parts and as usable parts, and no finishing or other secondary operations are required on these parts. But certainly in many cases we may require sometimes secondary processing. So let us have a brief discussion on secondary processing, that is machining of plastics. So most of the plastic products are produced to a near net shape directly by the molding processes. So we have seen so many plastics parts manufacturing processes which are used to make plastic parts to a near net shape. So whatever products we see around us in our day to day life, most of the parts are processed by the various molding processes and they are used as produced. So no secondary operations are done on most of the plastic parts. But sometimes complex plastic products that cannot be directly processed or require finishing operations have to be machined. Sometimes there is a complex plastic product which has to be made in 3 or 4 simple parts which can be made by some of the processes which we have already covered. So now we have a complex or an intricate plastic part which is made into 4 different sub parts. Now these sub parts have to be assembled together to get the final product, and for assembly sometimes we may be requiring machining operations. So machining is a general term. We may be requiring a drilling operation where we need to make a hole inside 2 or 3 different plastic parts so that we are able to assemble them using the mechanical fasteners. So sometimes the secondary operations in terms of machining also becomes imperative for the plastic parts. So all the plastic materials such as thermosets and thermoplastics cannot be machined easily. So there are issues and challenges which are not similar to the challenges that we see in machining of metals. The machinability of plastics is entirely different from the machinability of metals. So in this particular case, when we have to machine a plastic, the issues and challenges are entirely different. So some of the plastic parts are soft in nature and sometimes they are flexible in nature, so it is difficult to machine them. So some of the important points that have to be taken into account while discussing the machining of plastic are the type of the cutting tool material that should be used for machining of plastics, and secondly the rigidity of the material being cut. So if the material is rigid, it sometimes is easier to cut, but sometimes when it is very flexible, it becomes difficult to machine that material. So machining of plastics is sometimes required, and the conditions and requirements for machining of plastics are entirely different from the conditions and requirements that we usually see in machining of metals. So the different types of machining operations that can be used for plastics are turning, drilling, milling, sometimes threading and tapping has to be done. Then sometimes we have to cut the plastic part into different pieces, and finally grinding. Grinding is most commonly not used in case of plastics because the finish that we get in case of plastics is very good and no secondary finishing operations are required, but sometimes some edges may have to be ground so that we have to fix the various plastic parts together. So basically different machining operations can be done on plastics, but there are the conditions and requirements which have to be satisfied when we have to machine a particular plastic material, and the definition of machinability for plastics is different from the definition of machinability for the metals. And we will see certain aspects related to the machining of polymer matrix composites, in which the matrix would be a polymer material or it would be a type of a plastic material which would be reinforced with the fibers, and what are the issues and challenges there, that we would be discussing in module number 7 when we will talk about the machining induced damage and the conditions and requirements which are specific to the machining of polymer matrix composites or the machining of fiber reinforced plastics. So with this we come to the end of module number 4, in which we have discussed 7 different lectures, and in 7 different lectures our focus was primarily to study the various processing techniques which are used for processing of plastics. Just to revise the techniques that we have used or we can say discussed in this particular module, we have discussed the casting process in plastics, we have discussed the extrusion of plastics, we have discussed transfer molding, we have discussed compression molding, injection molding, thermoforming, blow molding and rotational molding. So in our next module our focus would be on a different material and the processing of different types of materials which have properties similar to those of non-metals. Thank you.